So in 311 yesterday, depending on how long you had to work through it, depends on how far you got, obviously. That would be a proportional relationship, most likely. Time spent working and amount of progress through the lesson. So, well, you might have already done the homework, but I doubt you did the lesson on your own. What 3-1 was pushing you to think about is that the order in which we talk about something happening and how you emphasize your words, like if you're actually saying something, completely changes the situation. So 4 times 2.5, pause, plus 1 is different than 4 times 2 plus 5 and 1. Right? So these different students kind of compared those situations. The first one did the 2.5 and the 1 4 times, both moves. Second one just did a 1 and then 4 of the 2.5s. According to order of operations, though, this, my smartboard's going to be weird today again, apparently.
Still so fun.
All I have to do is hit Smart Ink and then it like wakes up. What should happen first according to order of operations? Well, in this problem, what should be the first thing that happens, Ava? Yeah, but we don't have any there. What's the E? Exponent. We don't have any there.
M is multiplication, so it's 4 times 2.
According to order of operations, unless I put parentheses in here, this part of the problem should be what happens first, the multiplication. Yeah, I mean, really, I just wanted you guys thinking through it. So, now, this is where people get confused. So, go ahead and head your paper with 312, or you could put like 311/2. And we're going to just title it, like, make your header expressions. And in your book, there's a math notes box all about the parts of an expression, and I'll probably show that to you here in just a second. But if you were working on your homework class and you got confused because it said like circle each term or things like that, those are all defined in that math notes box. So when we look at solving expressions, the order of operations actually gets written like this. And any other way that you've seen it written is wrong. No offense to your previous teachers. There actually could maybe be another couple ways. But why, and actually please write that on your paper, and if you can't remember that that's order of operations, you should make a note. If you write it straight across left to right, it's wrong. If you write it as a complete ladder, P-E-M-D-A-S, it's wrong. Why?
I think it's because so it goes parentheses and exponents and then multiplication or division. It's just which one comes first in the problem then, and same with addition and subtraction.
What do I keep saying that's kind of like mind-blowing, change reality sort of thing? There's no such thing as division, and there's no such thing as subtraction. Those letters don't actually exist.
What?
But saying that the order of operation is PIMA probably is a little bit less convenient than PEMDAS. Here's the deal. Division is multiplication. But it's multiplication of a fraction, of a piece, of a portion. Subtraction is addition, but addition of an opposite. So when we work through the order of operations, there is no separate stage for division. We do all multiplication and division at the same time, working left to right. So please, in between these, draw an arrow that goes from left to right. That's why we write it out like this, because when I hit those steps, I work multiplication, division left to right, and I work addition, subtraction left to right. Everybody got this? I see blank pages. I don't know why. Like 2 months into school, I'm having to beg people to like take a minimal amount of notes. So far, I've asked you to write down like 5 things. We're like 10 minutes into class. I really do try to make things easy for you guys. So then as we talk about modeling expressions, we can use our pluses and minuses, which CPM calls our algebra tiles. Right, so it looked at modeling 5 plus 3 times 4 plus 2. You will have probably on a mastery the option of how to model something and set up what you would see. You could do like a tightrope model, right, where you do the jumps and everything else. But here, they have separated their tiles. So here's your 5. Here are your 3 sets of 4, right? One set of 4, another set of 4, another set of 4. So that's your 3 times 4, which we don't have to use the dot if we don't want. And then 2 more. You can't just draw like a pile of pluses. You would want to separate them and write it out cleanly, something like this. Okay, so again, I'm just trying to run real quick through here. And then if you work through the lesson, you should not have really had issues with the problem asking you to circle the terms on your homework, because terms are denoted or identified by what? How do we know, like, this is a separate term than that? If you don't know, you should read what's on the board. What separates our terms is addition or subtraction. So now really subtraction doesn't exist, so we can just say addition separates our terms. But like this is not separated, this is separated, separated. So there are 1, 2, 3, 4 different terms here. Because remember, we can do this and combine it into one number. What's 3 times negative 2? Negative 6. Be careful with that sign. It's a negative 6. I'm just going to put it in parentheses because it's negative. What's 4 times 5? 20, right? That's why it's a single term. Even though there's 2 numbers involved there, it makes just a single number. We can do that operation. But then the addition or subtraction separates things. And then here we're just starting to get better at working with partial values. So try to find ways that we can merge things together and kind of make zeros if possible. Also, you may use your calculator. Now, as you saw in the mastery, I reserve the right to give you assessments and whatever else without a calculator, but you can use it if you want to, up to how much you want to practice. Any other big questions from 311 or last night's homework? Because 312 covers the same stuff. Like, we're going to go over this again, but any, like, big, major, like, oh, I totally didn't get that. Ava?
I just have a question.
Yeah.
So like when you ask us to put like the numbers together for like we're testing something.
Yes.
Could we do it like what is it called the with the pluses?
The algebra tiles?
No, not those. Like when okay, just a second ago we were just doing it. Those things.
What?
That thing. Yeah. When you divide.
To circle your terms?
Uh-huh.
As long as you can remember what things are in between them. Now, the way we really do this mathematically, so we don't circle them, is we put parentheses around them. So you could actually nest, which side, I don't exactly know what's called nesting, but like if you have multiple parentheses around each other, it's called nested parentheses. So you could parenthesis your 5 if you wanted to, and then parenthesis your 3 times 4, and then parenthesis your 2, and that's kind of like circling your terms. That's how we can separate them, kind of split them up. And then we look inside the parentheses and say, is there something to be done? Well, no, I can't do anything there. Oh, I can do that. And I can't do anything there. Does that make sense? Sweet. Other questions? Thank you very much for asking that. Yeah, right.
11 on the homework, like for the generic rectangle, is confusing to me.
So could you do me a favor and put away your sketchbook, and I will help you with 11. So I love the generic rectangle. And just to reiterate, guys, I'm always going to be honest with you. My buddy Dave and I last night were having a very heated conversation about multiplication. I'm not joking at all. I can't even make this up. About stacked multiplication versus broken up distributed multiplication, which this a long time ago was called the array method, and it was set up a little bit differently. But when we break numbers apart, they become easier to work with. So this was asking you to fill in the missing pieces of the multiplication rectangle based off what we see here. So this 100 came from 5 and whatever number was over here. So what would multiply by 5 to make 100? 20. So 20 goes here.
And 20 times
And then, ooh,
200.
yeah, so this has to be 10, which means here has to be,
70.
and here has to be.
35.
So what this was representing and what you were trying to solve is this was actually the multiplication of 27 times 15. But broken apart to do really the array method, or what we now call the generic rectangle.
Okay, I know what I've been asking.
which is also known as the area model. So just to get you guys familiar with that terminology, CPM also calls this the area model, because if you can imagine, like let's say I'm going to put in a pool, and actually the landscaping company I used to work for is currently filling in a pool. If I can get back to the snap videos, I'll show you guys at lunch or something if you want to. Interesting how they're doing it. But if I had a space for a pool that was 27 feet wide and 15 feet long, what would be the area? Well, I can break it apart and then add all these together, and I got it. Real easy. I really don't want to do this multiplication. Honest truth, I don't like multiplying. 2-digit or bigger, anything, like, it's tough. This makes it easy. Like, I will never say it is, like, easy, but that makes it easier. Do you have a question, 8?
Yes, could we review 3-7?
7. That's... So, I used to be able to hold my pen and still control the screen, and then they updated the software. So really what it's trying to get you to do here is group this together and say there's a move of 7. There are 3 moves of 4, or you could say 4 moves of 3, and then a move of 2. So when it says like what movements does this represent? A 7 move, 3 moves of 4, and a 2 move. And then you want to put it together, figure out what your total is, and try to group things differently and see what happens there, especially if you add parentheses in different places. So B is really trying to get you to play with it. According to order of operations, that's what we do first. But if I mess with it, and I like put parentheses there, that's going to change what I get. If I put parentheses even like here and not in front, like that's going to change what I get. So it just wanted you to play with, like, when I put parentheses in different places, how do I get different answers? There's not really like a right, wrong answer there. It's just play with the numbers. Which is one of the things I really like with CPM. Like, they start to just expose you to things as, like, play with this. Try this out. All right, 312. So if you don't have a header yet, please make sure you put expressions in there as a header. How are we doing, Mrs. Pettigrew?
Is it this?
He left it here during foundations, and then I guess didn't really look hard enough when he came in.
That's my dog.
Oh, I'm sorry. I should have known that.
But he's not reading The Hobbit and...
Mom is such a good dog. I love it.
Wait, did that expression say 7 plus 3 times 2?
So go ahead and get, like, label 312 and then throw an A on your paper.
There is no A. Oh wait, no, yeah, there is. It's on top.
So now we see something that we haven't seen. Right, that little 3.
Oh, I know what that is.
People know what it is, Eva. What is that?
It's an exponent.
Okay, but what does it mean?
So
Okay, I'll come back to you, yeah. Go ahead, sorry.
it means you do 2 times whatever number that's up there. Or no. I don't mean that. I mean like 2 times 2 times 2, and you do that how many times that 3 is up there. So let's say it says 3, you do 2 times 2 times 2.
So I want us to get on, so make like a little note box or something separate from this problem. So somewhere like off to the side, just somehow separate it. Yeah, just make a blob. I don't care. If you have 3 to the second, which also is called 3 squared, that means it's 3 times 3 because I need to do it 2 times. If you had 3 to the third, that means 3 times 3 times 3. If we had 3 to the fourth, that'd be 3 times 3 times 3 times 3. And we could keep going, but I doubt that you really want to. So please get those 3 examples down. 3 examples involving 3's. That's how my powers work. So just like multiplication is a shortcut, right? Multiplying, just shortcuts, adding over and over and over and over again. Notice how this is a shortcut for multiplying over and over and over again. So, I'm on a few different threads online where people have different conversations about different topics, and I'm on one about math. And they were talking about, there's this expression or like thing where people are like, oh yeah, there's no way that you can believe this, but about the number of stars in our universe and compared to the number of grains of sand on Earth compared to the number of atoms in a single grain of sand. So if Mr. Cabilo has started to expose you to this, atoms are tiny, like on a level that we can't even understand. So when we look at like the number of grains of sand or stars in the galaxy or like atoms in a grain of sand or whatever we talk about, we often have a base of 10 and then a power that's big. What that means is 10 times 10 times 10, 27 of them. So guys, that's 1 with 27 zeros.
Oh my.
It's a number so big we probably don't, well, we probably have a name for it, but the name probably doesn't even make any sense.
Yeah.
A 1 with 27 zeros. You got any idea, Estes? If we have a name for that,
Big number.
that's a real big number. That I think that is the approximation for stars in the galaxy.
Do me a favor.
Yeah.
We log into that.
That might
I got a screen.
100 notch.
Oh, that's the number.
All right, so back to A. We got this written down, right?
Yeah, I guess. I was about to say
Eva?
yes, ma'am, but you're not a ma'am.
I was reading so like when third grade I was reading a Weird But True book. And
Yeah.
and it said like 14 or 13-year-old boy has like about like 24 octillion, which is like 24 zeros. I don't know if it's true.
Yeah, we can look up the giant, like, so we can't do it now, especially because how much we're trying to fit in class today. But if you want to look up like the really big numbers, we start with million, right? Then billion, trillion, quadrillion, quintillion, septillion, octillion. I think I skipped one in there, but octillion, nonillion, and it gets crazy after that. But I think non-million might be 27 zeros.
That's
It would
weird.
actually be octillion.
Octillion, okay.
I thought non-million too.
So it'd be in the octillions.
That's
One
weird.
octillion.
100 octillion.
Yeah. All right. So I need to copy this down. Now here's the big thing about solving expressions that 7th graders have a hard time with. But if you follow my instructions, I promise you it will make things easier. Here's the issue with 7th graders, and really 8th graders or even freshmen. You all want to get to the end as fast as possible. Which, really, if I were to give you some life advice, just slow down. Enjoy middle school while you got it, because pretty soon you're going to be in high school and everything gets crazy.
That's what
Are we okay,
all
Nathan?
adults say.
I don't want to go to high school.
You're just so into whatever you're doing, you didn't even hear me say your name. I got Clorox wipes if we need, if there's something on the desk, I need you with me. Okay? So, here's the issue that people run into. We can only do one thing at a time, or we're gonna make mistakes. Because how the order of operations works, we gotta do one thing before I can get to the next thing. So, we have this note out on our paper, right? Parentheses is also a trap door. I have parentheses here, but they're not this kind of parentheses. What this means is parentheses that have math inside of them that I can do. This parentheses is just because it's grouping a -4. This parentheses is just because it's multiplying and there's nothing to do inside of it. So there is no parentheses here. So I can tell myself, like, okay, we checked that off. We checked for it. We don't have to do anything. Exponents, we got to do. So this, if you need to make a note off to the side, is 2 times 2 times 2. Well, what's 2 times 2?
4.
What's that times 2? 8. So this becomes 8. Copy everything else that didn't change. And this is where kids start to try to rush and they start to make their mistakes. Notice how I copied directly below where I was. Some of you need to like clean up your work a little bit. You got things written kind of all over the place and in different directions. Use your graph paper, use the structure of it, go straight down from where you were. Trust me, going out to the right, like continuing out to the right, does not help your brain. This will help your brain.
It makes me think it's a
Confusing
whole.
because
It's
then
like
you
a.
can't see like what number goes where.
Yeah.
It just looks like it's like continuing the math problem.
Does everybody have this? Because I'm nervous that people don't. Because I'm like watching and waiting for people to be looking up your copying. So what's the next thing we're able to do? We did exponents now. Those are gone. Isaac, what do we do next?
We multiply.
Yeah, we do this multiplication that exists. Because we know parenthesis right up against parenthesis tells us to multiply. Only do the multiplication. So negative 4 times 8. My answer will be negative. Because 1 negative. And what's 8 times 4?
32.
32. Now should I do, like, now I'm just at the addition subtraction step, so I have to make choices of what makes sense to make my life easiest. Brendan, what would make my life easiest here?
+3.
What do you mean? I agree with you, but I need a little bit more of why we're going to do that.
Wait, no. Because you can get negative 35, and then you can add 5.
Yeah.
Negative 30.
Group your teams. Right? You got good guys and bad guys. My bad guys should all team up before they deal with the 5. So add your 2 negative. Now, if I was you writing this work on your paper, I'd do a little bracket or something to show we added those together and got negative 35. Then plus a positive 5. What's negative 35 plus a positive 5? Negative 30, right? It brings us back up. If you had worked ahead of me and you got a different answer, because the order of operations. We have to work one step at a time. Okay? I want you guys with your teams to try B. I'll cycle around the room. Jalen, I'll come to you first. But with your team, try B. I'll write it up here just so you have it in case you can't see up on the TV. Negative 3 square. Now, okay, hold on. This gets really dangerous. Who's got a calculator? Anybody at your desk? Riley, type into your calculator the negative button, like down at the bottom, then 3, then hit the squared button. Which your squared button on a calculator is right here. It says x squared, but that just means whatever you've typed in, it's going to square whatever you typed in. So it doesn't actually mean x squared. It's down here next to the 7.
Oh, okay.
It's beside the 7. Your calculator is a liar. If he had pants on, they'd be on fire. This is going to give you a wrong answer in your calculator if you don't type it in correctly.
I don't like it.
Riley, what did it give you?
It gave
It gave you
me -9.
negative 9. But what happens when we multiply a negative with a negative? Positive. So here's the danger. Are we doing the opposite of 3 squared, or are we doing negative 3 squared? We can define that by putting some parentheses around negative 3. Now that means we're doing negative 3 squared. And actually, if you type that like that in your calculator with parentheses, then you'll get the right answer. So try to process through this with your team, but I just wanted to make the note, negative times negative makes positive. Just another reminder there. Yeah, give me just a second. I gotta go to Jalen, and then I will come back up to you.
Okay, so because first thing that we have to do is
Well, the 5 brought us back positive. So if the good guys, bad guys fought, and if the bad guys have a power of 35 and the good guys have a power of 5, they bring down the bad guy's power, whatever you want to say. They bring it down to 30, the bad guys still have. So you don't have any of those two positives. That's 0. You have like a code. So if you had, you don't have any of the problems we just wrote.
That's 3 numbers, only one is negative. So
Are you doing what you need to do right now? Can you get on task on your own? Or do you need me to babysit you and check on in with you every single problem? So your paper's So as we said, the first thing we got to do, is not a power, even though we already talked about it. Ava, you've been trying to leap out of your chair. What do I do? Are you confident? Because I haven't checked your work. But... Okay, if you can tell me what we got to do first, then you can come up and solve it.
Okay.
If you want to.
Okay, I do.
Okay, what do we do
So I
first?
have to tell you. Okay, so you have to do -2 plus 5.
Come on up. Show it up. Try to make your work clean.
Wait.
I mean, you can bring your paper.
That'd be police.
If you're done with that, you are able to go ahead and try 14 while we wait to get Ava's solution on here. But we'll talk about 13 in a second. But if you want to go ahead and write 14 on your paper and get ready to do that one.
Should we leave room for 13 or just...
Not really. It's more of a discussion problem.
Whoa, that's really weird. Anyways.
So you didn't drop straight down, right? That was...
Yeah, I didn't.
It's not negative. It's positive because your calculator lies.
I didn't do it on the calculator.
So what's negative times negative? Positive, right? So that's got to be +9. So first thing Ava did was parentheses, right? Even though it was an addition, it was inside the parentheses. So that is considered parentheses. Then she applied her exponent, and she caught herself that a -3 times a -3 is a +9.
That's not the
I thought it was so easy. 3-14 is so simple.
Oh, okay. So then 4 plus 9, that's 12.
Oh, we have to draw a diagram out there.
Quick
I need help.
Questions? Mr. Pearson.
You look at my thing really fast.
For what, 14?
Yeah.
No, we're about to do that together as a team.
So simple, I already did it.
So, hold up. So Katrina and Madeline looked at problem 12 and they're like, well, really, those pretty much involve the same numbers. Right, I'm going to drag this down again for a second.
We're at 3-13?
No, so they were having a conversation about 12. So listen to what's happening before you react. So they pretty much look the same, right? I got 3s, 4, some negative numbers, a 2. Are they the same? No, completely not, right? And this is all actually one term. So one thing that, Madeline noticed was, this actually only has 2 terms, the -3 squared, and then this whole thing. Whereas up here, we have 3 different terms, the -3, the center term, all of this counts as one term, and then the 5. So that's the biggest difference that Madeline noticed between those. So here in 14, how many terms do we have in 14 alive? Now I don't know where anyone is sitting because I moved you guys. Sorry. Hey, what are you doing, man?
Sorry, I'm thinking of...
So how many terms exist in the expression there for 14, like in this? It's tricky. Less than that, actually. Aiden? Adrian. I keep hearing Aiden in my brain. Dude, because you won't be quiet, my brain keeps jumping over that way, so I'd really appreciate it if you would stop talking so my brain can focus on what it needs to. 2 terms, because the plus is what separates it. This plus is inside of parentheses, right? That doesn't count as separating my terms. This is one term, and this is a term. So if your team has yet to solve this, please go ahead and completely simplify that, which means do all the math. When we use the word simplify, it means do all the math. I'm going to copy this over bigger if you need.
Oh, you guys, okay, here. So you guys know what 4 times 2 is, right? Guys,
Oh my god.
there's 2 that you guys know A or B. Listen,
Thank you.
You're very welcome, but you also have a textbook that has all of this stuff in it that you're supposed to have out, that the first slide said, get your textbook.
5 plus 8. 2 times 5 plus 8. 5 plus 8 equals 13. 2 times 39. Plus 2 times negative 3. 3 times negative 3 equals 9. So 30. 30 minus 9 equals 30.
You should be talking with your team right now. Questions, answers, all of it. All of it should go to your team. What are we making through for?
No, this paper's gonna pull out.
He's gone now. He's dead to me. What do we do first? Joey?
Oh, you do the multiplication inside.
We do the parentheses, but inside of parentheses, we still have to follow the order of operations. So multiplication has to happen first. It's kind of too dark in my opinion.
Oh no,
but
don't leave it.
What? I'm leaving it. Gosh, you guys are so reactive. 5 plus, now this is 8, plus 2 times negative 3. Now, still we're doing parentheses, right? So this is a step where what we're doing is parentheses. This is still a step where what we're doing is parentheses, because now this addition can happen. And this is not parentheses. I mean, it is, but there's nothing to do over here, right? What is this actually? Multiplication. So 3 times what is now 13, plus 2 times what is now negative 3. Now, I knew this was going to happen, but I have to disagree with Mr. Hudson from 20 minutes ago. There are very minimal times where you will see something where, because what we're doing is the same, you could do it at the same time. This is multiplication. And this is multiplication. So if I say I'm going to multiply on this step, I can do both. I can do my 3 times 13 is 39, plus 2 times negative 3 is negative 6. Right? So my bad guys take out 6 of my good guys, and I end up with 30.
You could have put it that. That would have been so much easier if you didn't have to do all that.
I'm not even going to explore that conversation with you, because what you're saying is that math would have been easier if we didn't do the math.
No, if you hadn't had to write all that out, it would have been like done like.
But would your brain have benefited as
No.
much?
Yes.
No.
Yes. My brain is the dog's brain, so that's why I would have benefited. Take the salsa.
Take the salsa?
Yes. Love that. You gotta take the salsa.
All right. So, when we look at these problems, and this is really good homework prep, and we only have about 5 minutes left, we're now working with partials, right? You may use a calculator to work through these, but you still need to write out the work. So for A, we should all write out 3 times the 8.63 plus 1, and then work vertically. I know you're not writing because you're tapping. Right. I'm actually probably just going to start to ask you guys to structure your work exactly like mine. I don't like trying to like put you in a box, but there are some things that just make it better for your brain, that make it easier to understand. So when I do the first thing I do here, and we'll just do A together, and then I'll let you guys work on B, C, D, and then I'll give you some answers up here. I'm going to do what I do and work straight down from there. So this multiplication needs to happen first.
Oh, is that 8.63?
8.63, yeah. So my plus 1 isn't going to change. It's just going to drop down. But this does change. 25 something.
25.89, I think.
Can we get a calculator verification?
I got that too. I just did the math.
Nathan, you with me? You got this down?
Do it now. Calculator, thank you.
Yeah.
Well, I know that you had a calculator too, so I'm asking for calculator verification.
Jalen has one.
Is it 25.89?
Yeah.
Yeah. I feel
I did that too.
So, if, hold up, and then I'm going to let you work. If we broke it up, we could do 3 times the 8, 3 times the 6, and 3 times the 3, and then put them all back together if you wanted to. But a lot of times, once we start working with like more difficult numbers, we will be using calculators. So if I'm being realistic with you, you're probably going to be using calculators for this sort of stuff. You can go ahead and do that now. And you really only need one person at your group with a calculator to tell you guys, like, okay, when we multiply, we get. And then when we add, I hope we can all get to the last step.
Wait, why is it 26?
Because the plus 1. Don't forget about the plus 1.
Yeah, but wouldn't it be 25.90?
So this is one whole, and its decimal's right here. Right, so it's in the ones place. Your brain is getting tripped up, and now you're getting stuck. It's got to go with the other ones place. So remember back when you were in like 5th or 6th grade, you would stack the decimals on top of each other and then do your addition? It's like that, we're just recognizing where it adds.
Wait, so if we wanted it to be 25.90, we would have to have a like.
This would have had to have been 0.01, so that would have been 100th, and that place could have added with that, but it's not, right? In this situation, it is not. All right, try B, C, D, and I will put some answers up here. Thank you, Laviva.
I have a question.
What would you do? You have questions or answers?
I have a question, because you were saying that like you could use a calculator or the math. Does it matter which way you like it?
Calculator's going to be faster. So when it comes down to like doing a lot of math and you like start doing advanced math, and I hate to say this, but like you're really just going to use a calculator to make yourself more efficient. Not that you couldn't do the distribution multiplication.
It's like the stack on top of the bottom thing.
I really advise letting go of that. Stacked multiplications, I mean, if it really makes sense in your head, that's okay, but
Because I feel like with a calculator I'm cheating. Now I know I know.
B's the same thing. It just happens in a different order. B's the same thing.
I'm so sorry.
Bless you. We should not be singing. We should be doing the math. Only look up here if you're trying to verify your answers.
Wait, what?
I'm just putting answers up here.
Whoa, I did the same thing. Let's see. Alright, so good. 2. Just 2. Look at this.
Got a little bit of a big answer.
He's the same answer, right?
I know. I already said that out loud, actually,
Oh, you
too.
did?
Yes.
Oh.
It is okay. I get it that your brain was probably focused in that moment.
Okay, how do you just turn 2 over 1?
Yeah, you can turn any number into a fraction by just putting it over 1.
Oh, okay.
So like you could make 3 2/5 improper, and then to multiply it by 2, you just multiply the numerator with numerator and denominator with denominator.
Oh, okay, so 3 plus 1 is 2 add
No, but you can multiply straight through denominators. To add with fractions, you have to have common denominators.
I don't
to print that and make sure I'm well aware of it. Alright, that is all the time that we have. I need to make sure I get you guys out to your next class. So here, give me your attention for a second. Here's what I need from you. I need you to really respect your practice for your benefit. Right? If you do not know how to do something, get help from someone, use the homework help online, get help from me, or ask in class tomorrow. But before you ask in class tomorrow, you need to try to figure it out somehow. Okay, homework help, a peer, a parent, me, whatever. Have a wonderful day, guys. Thank you so much.